Hey guys, as some of you may or may not know, I coach more than one team, and I've had people ask me about wheel selection. Do we use the solid rubber wheel, or do we use the omni wheel, and do we put the rubber wheel in the front or back, and why do we do this, and what effect does it have on the way the robot handles? Okay, as we're going to show you here, it can have a really big impact on the way the robot handles, and I'll explain it to you, and you make your own mind up about how you want to design your robot going forward. As you can see here, we've got two robots that are virtually identical. This one happens to have some claws on the front, but other than that, they've got the same frame, same drivetrain, they're the same size, except rubber wheels on the front on this one, rubber wheels on the back on this one. Okay, as you know, the rubber wheels don't really slide on the playing surface. Okay, now the Omni wheels, they will slide sideways, and that's a good thing. You can use that to your advantage. But what that means is, if we look at this robot first, you get the rubber wheel on the back, so you tell this robot to turn, and it pivots on these back wheels because they don't slide. They won't slide sideways, okay? The front wheels will slide sideways. And on this one, they pivot here, sort of in the middle of the entire robot, and the back wheels slide sideways. We're gonna show you this real quick with an example using a beam here. If we take this little beam, and we say, okay, the rubber wheels are at the back, so they're going to pivot, so they're not going to move, they're not going to slide. The robot's going to move like this when you try to turn. The back end's going to pretty much stay in one place. The front of the robot's going to move back and forth a lot. Now, if you use the wheels in roughly the middle of the robot, the rubber wheels, when you turn, the robot's going to act like this. It's going to go back and forth less, and the back of the robot's going to swing out in the opposite direction. Okay? Now we're going to show you just exactly how much the difference is. If you look at this wheel, we've put a magic marker mark right here so we can tell when we've turned one complete turn, and we've got one on this robot over here as well. We're going to turn one turn, we're going to measure how much the front of the robot swings, and we're going to show you that measurement. All right, here we go. All right. The robot was lined up with the black line, and now the front of the pusher moved sideways about 10 or 10.5 inches. Now we're going to do this second robot with the wheel at the back, rubber wheel at the back. And the front of the pusher has moved about 14.5 inches to the side. So, as you can see, it has a big difference on how much the front moves back and forth during your turn. So this year, if you had rubber wheels on the back of your robot with Omni wheels on the front, and you're wondering why you were knocking hubs over, why the robot was hard to control, that's probably why it was happening. So now that you know, you can make your own mind up about how you want to design your robot and the impact that's going to have. We did try Omni wheels on the back and front, and we found that it was very, very hard to get a good autonomous run because the Omni wheels are a lot more unpredictable, and the drivers on the team did not like the Omni wheels everywhere because when they were doing driver control, the robot was a lot more unpredictable. So that's it for this video. Thanks.